Okay, guys, for this week, we take a look of the identity and domination. I think this one I have explained to you for the domination and also for the identity. Okay, for the identity law, P uh, conjunction T true is equivalent to P means that the conjunction of any sentence of P with arbitrary tautology of T will always have the same truth value as P. It will be logically equivalent with P for P is either true or false. If it is true, then P and true will be also be true. Okay, because both conjunction are true, then if it is false, then P and T will always be false. Because one of the conjunction false. So whatever truth value P has, P and T will have the same. Okay. Similar reasoning applies to second identity law. For example, false. Okay, this one for identity. Okay, now we take a look for domination law. Uh, P conjunction T is always is equivalent to true. P or true. This one is disjunctive. This one conjunctive. Okay. Okay, please write some notes because this one is uh, this one is for revision last week. Please take note. Now take a look for the first domination law. P or true is equivalent to true. It means that the disjunction or disjunctive of any sentence of P with arbitrary tautology of T will always be true. Okay, will be a tautology. Okay, this because if you have disjunction and you know the that one of disjunct is true, then you don't need to know the truth value of another disjunctive anymore. To know that the whole disjunction is true, for if P were true, then the disjunction P or true T will be always be true. But even if P were false, the disjunction would be true because the truth of the tautology suffices to make the disjunctive to be true. Okay, if it is conjunctive, okay, this one conjunctive, and then this one should be false because for the disjunctive it will be the tautology. Okay, for this one. Okay, for false it will be false. This one for domination. It is reversible for the identity. Okay. Okay. So far, do you have any question? Is it okay? Is it okay, guys? It's not complicated, isn't it? Okay, and that, huh? Tak okay? Apa yang tak okay tu? Okay. Okay. Okay, and then we have absorption. Okay, we have absorption and negation. Okay, for the absorption, same. The repetitive variable. Okay, as you can see, we have the outer and inner. Okay, we have outer and the inner. This one is the outer and the inner is the same. Same. Okay, and then the repetitive variable for the output is equivalent like this. Okay, same goes to conjunction and disjunction. This one is disjunction. This one is for conjunction. Okay, this one is a repetitive variable. This one is absorption. Okay, and then we have negation. Negation. We negate the p. We negate p. For the disjunction is true, and for the conjunction we negate the p. For the identity is false. And then we have the distributive law. Okay, for the distributive law, you can see for conjunction, disjunction is equivalent to conjunction. Okay, this one, okay, distributive law, which asserts that A plus B plus C is equivalent to A plus B plus C. Okay, like this. This one I have explained to you. Equivalent to. Okay, this one is distributive. Okay, is it okay? So far, okay. Okay, next. Okay, this one is distributive. We have all here. Okay, N. Okay, this one N. Disjunction and conjunction. And then for the distributive, we for the P or Q. P or Q. Okay, and then uh, we solve the outer side first, and then the inner side. Okay, okay, and here we put N here, and then P or R. Okay, same goes here. P and Q. Okay, and then we have R because here or P and R. Okay, here also same. This one is reversible, distributive. Okay, P or Q and R. Okay, P here, Q. Okay, Q here. We combine. Okay, and then we have Demorgans Law. Demorgans Law, if you take a look for this one. Okay, we have the negation P or Q is equivalent to negate P and negate Q lah. Okay, and basically Demorgan law is to simplify the Boolean expression lah. Okay, because we have the first and the second law of De Morgan. Okay. Okay. Later we see this one in English. For De Morgan law. For time being, we see this one in the proposition. Okay. Okay. If for the English, if Px x has three wheels, then the denial of there is a car with a three wheel is every car does not have a three wheels. This one is the same. Okay, for example, we have negation, negative, okay, is equivalent to negative x, negative y. Okay, same goes here. Have negation p or negate q is equal to negate p and negate q lah. We want to remove the negation by negating outside lah. And then we have negate p and q lah. Okay, because we solve the inner side to the outer side lah. This one. Okay, same goes here. Okay, we have a negate a p and negate q. We have a negate p or q lah. Okay, for conjunctive, we have disjunctive. Okay, and then same goes here. P and negate q is equivalent to negate p and q lah. Here, okay, we just exchange. Okay, then we have double negation. X plus y is equivalent to negative x, negative y. Because negative will be positive, and negative will be positive plus y. Okay, this one is just a review. And then we have Demorgans law by the double negation. Okay, and then we have here first proposition and is equivalent to second proposition. This one, if you see, is conjunctive. Okay, will be same as disjunctive. Okay, this one is distributive and absorption. Again, P repeated to absorb the Q, and then we have the repeated variable. We call it as absorption. And then for the distributive, we have a P or Q and R. Okay, equivalent to P or Q and P or R. Okay, yeah, and okay, then we have a series of equivalences. A series of equivalences. We have the and then we have the negation, and then we have a domination. Okay, this one I have explained to you. Okay, the commutative. Okay, for professional logic, we have a series of equivalences. Okay, first show the P or Q or negate P is a tautology. Tautology I have explained to you. Okay, we have two proposition that have a same value. And then for disjunctive, true value will equivalent to true. And then when conjunctive, false will be false. This one is domination. Okay. And then we have a commutative and negation. This one is commutative. P or Q or negate P is equivalent to P or negate P or Q lah. And then this one is true or Q, and then we have true lah. Okay, the last one is the domination. Okay, domination. Okay, this one we go for by the negation. This one is commutative, series of equivalences. Okay, so far, do you have any question? Is it okay? Why your voice so weak? Commutative mean that involving the condition that a proposition connected give the same result. Okay, for example, we have A multiplied by B multiplied by C. Okay, and then is equivalent to A multiplied by B multiplied by C lah. Okay. Okay, this one I've explained to you. We have the tautologies, two variables here. P is P1 and Q. We have 2 power of 2 is equivalent to 4. Lah. 1, 2, 3, 4. Lah. And then we have here all the truth value because we have the combination of the uh, disjunctive and okay, or and or. Okay, and then this one tautology because P or Q or negate P is always be true. Lah. All the output true are called tautology. Okay, we have important equivalences involving the implication. Okay, implication that I have explained to you. We have the implication for logical equivalences. Okay. Okay. For example, here we have H for hypothesis, C for the conclusion, C for the conclusion, and then we have a contrapositive. For the contrapositive, you should inverse first. Okay. This one I've explained last week. We have hypothesis, and then we have conclusion. We negate the hypothesis, and then for all conclusion. And then we have P implies Q is equivalent to negate Q implies negate P. This one is contrapositive. Lah. Okay, and then for the three conditional statement, we have P implies Q and P implies R. Okay, is equivalent to P implies Q and R. Same goes here. Uh, P implies Q or P implies R is equivalent to P implies Q or R. Okay, and then for the biconditional is conjunction. Conjunctive. It's not a disjunctive. Or cannot. It must be conjunctive. Okay, this one is for the implication equivalences. Okay, again, contrapositive. You have I have discussed with you last week. Okay, please refer back to the videos last week. Biconditional is statement that a statement combining a conditional statement with converse. With the converse. Okay, we learn converse. We learn converse, inverse, and contrapositive. Okay. Okay, and then okay, this one is just a revision. We have inverse, converse, and contrapositive. First, we negate the hypothesis or the conclusion is maintained. And then we have the conditional statement P implies Q is equivalent to negate Q implies negate P. This one is contrapositive. Okay, contrapositive. because we change the position for the converse, and we put the negation here. Not okay to be contrapositive lah. Okay, and then this one is a conditional statement for one, and secondly is contrapositive lah. For this one is hypothesis, P is conclusion. Okay, and then we have how many here? Two variable, 2 power of 2 is 4 lah. Okay, 1, 2, 3, 4. Okay, because we have P and we have Q lah. Okay, and then P implies Q. Okay, true, true, false, false here. And then here we have a true, true, false, true. Is equivalent. Equivalent here you can have like this or like this. Equivalent. Okay, this one is just exercise. Okay, show that negate P implies Q and P and negate Q are logical equivalent. And secondly, show that negate P or negate P and Q and negate P and negate Q are logically equivalent. Okay, you should do like this, from left to right and right to left. Okay, first left to right. Okay, negate P implies Q is hypothesis and conclusion. First, you do the implication. Secondly, equivalence, and then Demorgans Law lah. And then you double the negation lah. Okay, P and negate Q lah. Okay, and then for the right to left, P and negate Q. Okay, we have hypothesis and conclusion for Demorgans Law. And then you do the implication, equivalence, and double negation lah. And you have negate P implies Q lah. Okay, okay, it's same lah. Okay, logically equivalent. Okay, okay, you implies first the implication for left to right. Secondly, you do the equivalence. Okay, secondly, De Morgan and double negation. For the right to left, first De Morgan, second implication, equivalence, and double negation. Okay, same goes here. Okay, we have P and Q implies P or Q is a tautology. And then we have a complex operation here for hypothesis and conclusion. We have implication, equivalence, De Morgan, commutative, negation, and disjunction. Okay. Okay, for equivalence, negate P and Q or P or Q and then De Morgan. Okay. Uh, okay, wait. Okay, is it, do you have any questions so far? You okay? Okay, Kalista, is it okay for you? Okay, this one for the Demorgan, and then we have commutative. Okay, we have commutative, negate a P or P, and we have negate Q or Q lah. It is the commutative, And then last one is negation. True or true is negation. Okay, wait for a moment. Okay, and then we have true here. Okay, and then negate P or negate Q or okay, this one is okay for the disjunction. Okay, this one is proven. Show that equivalence negate P implies Q and P and negate Q are logically equivalent. That we prove by put the negation. Negation P implies Q. Negate P or Q, and then we have P and okay because this one negate Q lah is proven lah. It's just like this lah. Okay, and then we have the answer. Is tautology. When tautology, you need to do like this. Okay, negate P and Q or P or Q first, and then put the Demorgan. Okay, Demorgan law, and then after that you have the commutative. Okay, and then true or true is true lah, is proven lah. Okay, we rest 5 minutes after that we continue lah. Is it okay? Kita rehat 5 minit